Hello everyone, myself Yash Sanjay Suryavanshi, studying as a student in MVP's Karmavir Advocate Baburao Ganpatrao Thackeray College of Engineering in the first year Information Technology branch. Today, we, the group members of roll number 59 to 64, are hereby presenting our first year Basic Electrical Engineering project on the topic Different Types of Lithium-ion Batteries. My roll number is 64. Let's begin. So, what is a lithium ion battery? A lithium ion battery is a family of rechargeable battery types in which lithium ions move from the negative to the positive electrode during discharging and from the positive to the negative electrode when charging. They boast of properties like high energy density, which is a very important parameter due to which they are used in an array of electronic as well as electrical devices like cell phones, TVs, watches, etc. So let's see the working of a lithium ion battery. A lithium-ion battery is made up of an anode, cathode, electrolyte, and a separator. The anode here is graphite. Lithium is also present between the graphite molecules, and the cathode is a lithium metal oxide. It can be cobalt, manganese, nickel in place of the metal oxide, etc. Let's see the structure of a lithium-ion battery and let's discuss the process of discharging. So, during the process of discharging, the electrons move from the graphite anode, that is the negative terminal, to the positive terminal, that is the cathode. As the process of discharging goes on, the electron number at cathode increases. As a result, the negative charge at the cathode also increases. We all know that an electron won't get attracted to another electron, which will lead to improper cell functioning. To avoid this, the lithium ions formed during the process of discharging at the anode move towards the cathode to neutralize the negative charge density increasing at the cathode. This is the process of discharging. During the process of charging, during the process of charging, an external power supply is connected to the battery. It forces the lithium ions present at the cathode back to their original place at the anode. The electrolyte. The electrolyte is basically lithium salt in an organic solvent. It is the reason due to which during discharging lithium ions move from anode to cathode. During charging, they move back to the anode. A separator avoids the meeting of cathode and anode, which may lead to the stopping of the cell functioning, battery functioning. Let's move ahead. Let's see some important terms before starting. Cell voltage. Cell voltage is the difference in the electric potential between the anode and the cathode. It is measured in volts. Second, life cycle. Life cycle is each round of full discharge and then full recharge. Example, XYZ has 700 to 900 cycles. Specific energy. It is the amount of electrical energy stored for every 1 kilogram of battery mass. The unit is watt hour per kilogram. Next, thermal runaway. Thermal runaway is the process that occurs when the cell reaches a certain temperature. Chain reaction occurs, and the chain reaction may be uncontrolled heating or cell short circuit. Energy density. The amount of electrical energy stored for every 1 cubic meter of battery volume. The unit is watt hour per meter cube. Capacity. Capacity is the amount of energy stored in a battery. It is measured in watt hours. Now let's finally see the classification of lithium-ion batteries. The first type, lithium cobalt oxide battery, lithium manganese oxide battery, iron phosphate battery, nickel cobalt aluminum battery, titanate oxide, nickel manganese cobalt battery. Let's see the first type, lithium cobalt battery. The cathode material here is lithium cobalt oxide and the anode material is graphite carbon. A visual representation of it and some specifics. Cell voltage is 3.60, nominal voltage is 3.60 volts, life cycle is 500 to 1000, specific energy, important characteristics of the cell, 150 to 200 watt hour per kg, and thermal runaway is 150 degrees Celsius. Let's move ahead. Properties of LCO, lithium cobalt oxide. It has very high specific energy, deliver power over a long period of time, and this one of the reason why they are used all over the world. They are very tiny in size due to which they can be integrated into portable devices. Limitations are, as cobalt is an expensive material, the battery is also expensive. The lifespan or the life cycle is very short. They need to be recharged. They also cannot be used on high load applications. Applications of LCO are: it is most commonly used in laptops, cell phones, cameras. Now I hand over the presentation to my friend Sumit Sonone.
Myself Sumit Sonavne, roll number 62. I am going to explain the second type of lithium-ion battery, that is lithium manganese oxide battery. This type of battery has separate categories of batteries which uses manganese oxide as its cathode and graphite as its anode, which is treated at 350 degrees Celsius. This is the 3D representation of lithium manganese oxide battery. Here are some specific characters of lithium manganese oxide. Value for cell voltage is 3.80 volt nominal. Life cycle is 300 to 700 cycles, which itself is very less. Specific energy is termed as 100 to 150 watt hour per kg, and the thermal runaway is 250 degrees Celsius. If you want to convert it in Fahrenheit, so it becomes 482 Fahrenheit. Coming to cell reaction, in cell reaction at anode, lithium undergoes oxidation to form lithium ion plus 1 electron, and at cathode, manganese oxide undergoes reduction reaction to form lithium manganese oxide. Here at cathode, at LHS side, the manganese oxidation number is plus 4, and after reduction it becomes plus 3. Hence we can say that at cathode reduction takes place, and the overall reaction is Li plus MnO2, that is lithium plus magnesium oxide, gives LiMnO2, that is lithium manganese oxide. Moving further to the properties of lithium manganese oxide. First property is what? They have lower internal resistance due to their 3D structure. Here it means that the lower internal resistance, that is the current flow, is in good way. High temperature stability distinguishes lithium manganese oxide battery from others, which are also safer than other lithium ion batteries type. Here are more some properties. They are capable of fast charging like LCO. LCO stands for lithium cobalt oxide. They also have high power. They are safer and stable than LCO. But even though this type of battery is safer and than other battery, but it also consists of some limitations, which are they have less specific energy, and also they have very less life cycle, that is nearly 300 to 700 cycles, as we had seen in specifics. It consists of some applications which is very important. Mostly it is used in the power tools which are worldwide. It also used in the watches, calculators, automatic cameras, and many consumers electronic devices. Now I hand over the presentation to our next group member. Thank you.
Myself Swati Sonone. My roll number is 61. I am explain the type 3 lithium iron phosphate. The lithium iron phosphate battery is a type of battery using lithium iron phosphate as the cathode material and a graphite carbon electrode with a metallic backing as the anode. Because of their lower cost, high safety, low toxicity, long cycle life, and other factors, the lithium iron phosphate batteries are finding a number of roles in a vehicle's use until it is scaled stationary applications and backup power. There are some specifics of values. First is cell voltage. Their value is 3.20 or 3.30 volt nominal. Second is life cycle. Their value is 2000 and higher. Third is specific energy. Their value is 90 to 120 watt hour per kilogram. Fourth is thermal runway. Their value is 270 degrees Celsius. Next point is properties. The properties of lithium iron phosphate. First is these batteries have a moderately energy density of 90 to 160 watt hour per cubic meter. Second is similarly to LMO. The lithium iron phosphate chemistry have low internal resistance, resulting in higher thermal stability. Third is unlike the LCO, these batteries are more durable. Fourth is lithium iron phosphate batteries have one of the best life cycles, making them a very cost effective option considering their long operations life. The next is limitations. The limitations of lithium iron phosphate. First, the nominal voltage is 3.2 volt of the lithium phosphate battery, means that it has less energy than other types of lithium batteries. Second is its performance is greatly affected by temperature, especially in low temperature environment. The discharge capacity gets reduced. The next point is applications. The applications of lithium iron phosphate. First is the lithium iron phosphate battery are used in industrial equipment and heavy machinery. Second is they are widely used in environments, especially in electric bikes, electric rickshaws, and many cars because of their ability to withstand a lot of mechanic and thermal abuse. Now I had over representation to my next group member Rutuja.
Myself Rituja Suryavanshi, roll number 63. I am going to explain four type of lithium ion battery, that is lithium nickel, cobalt, aluminum oxide. It is known as NCA batteries have combination of nickel, cobalt and aluminum as active material in cathode. It is used in cathode material for lithium ion secondary batteries and mainly used in electrical automobile. The NCA battery generate power through chemical reactions between anode and cathode within core of NCA batteries, and they have specification is cell voltage, that is 3.60 volt nominal, and there is a life cycle is 500 cycles, that is one cycle means one time charging and discharging, and there is a specific energy means it is a battery capacity in weight, that is 200 to 260 watt hour per kilogram, and there is a thermal runway is 150 degrees Celsius, that is up to 302 degree Fahrenheit. Now let's see properties of NCA is it is one of the most energy dense lithium ion chemistry with energy density is high up to 260 watt hour per kilogram, and they are rich in power density, and also they are high in specific energy and long lifespan. It is excellent to fast charging capability, and they have some limitation is lower thermal stability, high cost, and it has limited resources of cobalt and nickel. Now let's see application of NCA is Tesla motor used in NCA battery in the electrical vehicle, and they are also used in medical devices and industry application. Now I hand over in my presentation to my friend Priyanka Shinde.
Priyanka Shinde, roll number 60. I am going to talk about LTO battery. LTO stands for lithium titanate oxide. This is modified lithium ion battery. It uses lithium titanate nanocrystals on the surface of anode. Let's take a look at some numbers. First, cell voltage is 2.40 volt nominal. Second, life cycles of LTO battery last up to 3000 to 7000 charges. 3. Specific energy of LTO is 50 to 80 watt per kg. Now moving forward to properties of LTO. It has very high rate of charging and discharging. LTO battery has great battery like as lithium titanate nanocrystals are used instead of carbon. It is one of the safest battery. Excellent low temperature and discharge characteristic. Limitations of LTO. LTO battery suffers from low nominal voltage, low voltage and energy density of 2.4 volt and 50 to 80 watt per kg. Applications of LTO uh, due to its safely features is used by Honda's Mitsubishi into their electrical car. Solar power street lighting uses LTO battery. Next slides will be explained by Karthik Shinde. Thank you so much.
Hey guys, It's me, your Suryavanshi, here again. Due to some unforeseen, unfortunate circumstances, our friend roll number 59 could not be here with us today. So I'm taking over his work and explaining to you the sixth lithium ion battery type, that is lithium nickel manganese cobalt oxide. So lithium nickel manganese or NMC batteries uses a combination of nickel, manganese, cobalt as the active material for its cathode. The most common used ratio, that is the percentage when in mixture of cathode, is 60% nickel mixed with 20% each of manganese and cobalt to form the alloy. This is an example, and let's see some specifics. The cell voltage is 3.60 volt to 3.70 volt nominal. Life cycle is 1000 to 2000 cycles. The specific energy is 150 to 220 watt hour per kg, and the thermal runaway is 210 degrees Celsius, which is considerably higher. Let's move ahead. Now, NMC advantages and limitations. So, NMC has high capacity, that is the amount of energy stored. They are able to deliver high power. The combination of NMC, the mixture and the cathode, makes them give very high continuous discharge current. They are also safe and durable. Let's see the limitations. The battery life here is moderate, that is 1000 to 2000 cycles. Due to cobalt, the battery becomes a little more expensive. Let's see the applications. Now, NMC is used in medical equipments, EVs, and many other appliances of the sort. Now, I hand over the presentation for its conclusion.
We all would having question in our mind that which types of batteries are mostly used. So here are two types of batteries which are mostly used. First one is lithium cobalt oxide and second is lithium manganese oxide. Lithium cobalt oxide batteries are used in cell phone, laptops, tablets, digital cameras and many other devices which are used all over the world. So there should be no surprise that they are most common type of lithium batteries. After LCO, lithium manganese oxide is on the second rank. Due to their high temperature stability and safety, they are used in various appliances all over the world. Thank you for watching our presentation. If you loved our video, don't forget to like, share and subscribe.